Welcome. I'm Andy McMillan, President of BACnet International, and I want to welcome you to this first participant activity in the BACnet SC Interoperability Acceleration Program. As you know, the program has three objectives. We want to speed up the availability and acceptance of BACnet SC, accelerate interoperability of BACnet SC devices, and support test labs with products and test services. So there are four elements in the program. One is development of a reference implementation. The second is a series of technical seminars on relevant BACnet SC topics, of which this is the first one. The third element is a forum for discussions and questions and answers regarding the implementation and BACnet SC deployment issues. And the fourth is the development of some BACnet SC test capabilities and services. So I want to thank all of you for your participation and all of your companies for being participants, because industry collaboration is the fastest and simplest way to get where we need to be with accelerating BACnet SC in the real world, solving real problems for real customers. Our intent is that this program serves your needs to help you get your products and solutions to market faster. So over the course of the next 6 months or 12 months as we go through this program, if there's something that we can do to make it serve your needs better, please let us know. Now let me introduce our panel for today. Dave Robin, a longtime member of the SSPC and former chair of that group, is also author of substantial parts of the BACnet spec and a member of the working group that created BACnet SC. He's an experienced BACnet technical thought leader and BACnet software developer, clearly one of the world's experts in BACnet SC. Our other panelist is Carl Nielsen. Carl is the technical advisor for BACnet International and the BTL. He also is a longtime member of the SSPC and a member of the working group that created BACnet SC. He has also been a longtime member of the BTL working group, and so is also an expert in BACnet test and requirements for BACnet products. So we have a lot to cover today. We hopefully address some of your questions in the content we've prepared, but you may have other questions that we didn't consider, or perhaps the content will raise some questions you haven't thought of yet. You can submit those questions to us using the question control on the control panel on your screen. If we can answer them as part of the prepared content, we will try to do that, but we already have a rather full agenda. So questions that are submitted here and not answered will be entered in the program forum at the URL on your screen. We'll make sure the questions entered there are answered over the next few days. So if you haven't already signed up for the forum, do that right after this webinar. You'll want to know we're recording this webinar, so if you want to go back and access it again later, you'll be able to do that. And the slides that we're using will be distributed through the forum if you want to go back and take a look at them. All right, with that, let's get right into the content of today's webinar. So I'll turn you over to Carl.
Welcome, everybody. For this first webinar, we're going to be doing a question and answer period. I'm going to be throwing questions at Dave, and with his awesome skills, he's already got his answers ready for presentation here. So this first set of slides or webinar is on the reference implementation that he's been working exceedingly hard on. And so, without any further ado, Dave, what can you tell us about your reference implementation?
So what is a reference implementation? It's a reference implementation of this, our favorite published addendum to BACnet. Addendum BJ is live, as we say, it's out there. And so somebody had to write some software that matched it. And of course, that somebody is probably a lot of those logos that you just saw in the previous slide. I mean, lots of people are working on this. It's getting huge traction attention. And so since there are a lot of us doing it, it's time to start making sure our code all works and do some testing and stuff. So what a reference implementation of is basically a community vetted implementation of the standard. And I guess you could have a reference implementation that is just, something that Microsoft produces and everybody accepts. You could say that's a reference, but a better reference implementation is one that everybody gets a chance to look at, everybody gets a chance to see the source code, and that's what we're doing. So taking something familiar like these state machines from the standard, that anyone's involved with the standard recognizes these very well. They were debated and talked about a lot. So they have words and stuff that we're familiar with. Well, the reference implementation that I'm writing is designed to be familiar to that. So even though I might not like some of the words or some of the transition names or whatever, the code matches it. So it's designed to be exactly like the standard. It's designed to be familiar and therefore verifiable, not clever. It's not one thing that a reference implementation is not, is a high performance, highly optimized, highly platform specific version of code that runs fantastic on your platform. It's designed to be a correct implementation, and so that will run on any platform really. But the main thing is that it be understandable. Everybody who looks at it can verify, yes, that's correct. That is what the standard says. So speaking of everybody, one of the main things we're doing to ensure correctness of the standard of the reference implementation is this: giving it to you guys, giving it to everybody that is a member of the participants of this program. We want it to be open for comment, review, and correction. So the more eyeballs, the better. And speaking of which, one of the things that we do is right up at the top, you might be noticing it says extension, not in YY1, but should, or 11, but should be. Well, that's correct. This is the kind of thing that this group will do with the reference implementation, that is identify gaps in the standard and then agree on what we should do about that. So there's a couple of cases, I'll show you another one later on, where there's things that just weren't in the standard that are in the reference implementation. We'll eventually feed that back into the standard and make it part of the standard by with either errata or addenda to fix the standard or extend it. But in the meantime, we can all look at this code and go, yep, I think that's what we should do in this situation. So also, what is the reference implementation? It is not the do-all, be-all, end-all BACnet stack. It's not trying to be a complete BACnet stack. It does just enough to do routers. And that's what this project needs. That's what we all need. And so it implements the BACnet SC, of course, but it also implements BACnet IP as well, and then a minimum network layer in order to tie those two together, and a very minimum application layer just to have the device object and the required properties. It does read property multiple, mainly for scalability testing, so you can do request giant APDUs using read property multiple, so that will be valuable. Other than that, it's very simple. So that's what a reference implementation is. Hope that answered your question.
That does, and it sounds like there's a lot in there, but how might this reference implementation be useful to the program participants in their SC development project?
Well, it depends on what you want to implement, and a lot of the full line manufacturers perhaps are going to be implementing routers and hubs and nodes anyway. So at least we'll get to the part where it can be useful in testing, and it has a lot of testing features. But for someone who just wants to create nodes, for example, here you go. The reference implementation can be used to provide the other pieces of the puzzle, the hub and the router. And so if you're developing a node, the little green guys down there, certainly you need a hub to talk to. So right out of the bat, you don't have to implement all the hub features. You just write your node code and your node connects to the hub, the reference implementation, and you're done. Problem is, all of your tools that are actually going to send an APDU, a read property request to your little node are probably on IP. And so you haven't, because those tools, your little handheld, whatever kind of explorers or front ends you've got, they're probably IP today. So a critical piece of this testing is the IP router. So the reference implementation gives you the router and the hub so you can develop your nodes and you don't have to worry about it. And then, of course, you hopefully benefit from the transitive property of if A can talk to B and B can talk to C, then A can talk to C. That's one of the reasons why we all hit on the reference implementation. And if we can convince ourselves that we can do all kinds of possibilities with the reference implementation, that hopefully then the vendors can talk to each other. And as we mentioned before, there are these extensions, things that were just not anticipated. There's no error code for when a payload is, expected but not there, or it's there but it's not supposed to be there. Things like that. So we can agree on what the correct error message is there, and so that's something the community can benefit from. The main feature, though, that makes this different, it's interesting. It's a reference implementation is a correct behavior of the standard. That's one aspect of a reference implementation. So take that hat off for a second and say, what would be a really cool testing tool? So this, quote, reference implementation is also designed to misbehave. And this is a big key about what its usefulness is. When you're running this thing, it has manual commands. You interact with it through a little console, and you can do these things that are on the screen. You can bring the primary or up or down, but the really cool thing is you can basically make it do things that are little out of the ordinary, and that helps to test your code, whether you're writing a node or a hub or whatever you're doing. Getting this guy to behave strangely is great. For example, simulating my favorite one is reject the next connection request as a duplicate BMAC. I don't actually have to set up a case where I have a node with a BMAC and then another one with the same one trying to connect. You just simply tell the guy, whatever the guy says, reject it as a duplicate and see what he does. And you can do that again and again and again. And finally he comes back and say, okay, yeah, you're in. So anyway, you can see all these other things. You're sending messages, you send unexpected messages, send it in, you're in the middle of the connected state, and all of a sudden you send a connect request. What's he gonna do? So some of these fall into the category of negative tests, but, and I didn't focus too much on those negative tests, but I did focus on things like, what would your implementation do in the field if it got one of these by accident? So in addition to those, which are basically message-oriented things, here's some of the behavioral implemented things. You can say, stop initiating heartbeats, stop responding to heartbeats, all these kinds of things. And then the bottom category is really down into the minutia, and you think, well, these really do sound like negative tests, but because you have these options, somebody might decide to put a proprietary option in there and say, and they mark it as, don't worry, you don't need to understand this, but I'm sending you this proprietary option that you may or may not know. Well, he might send you 2 of them, which means that you have to properly handle the chaining, the more follows option. And if you don't, then you're going to break when you meet that person in the field who's doing a totally legitimate thing. This is not a malformed packet in any way, but you need to be able to handle this kind of stuff. So this is set up to create these kinds of messages that are sent to you either in responses or in requests. And that is where I'm really excited about this. This is way more than just a reference implementation of the correct behavior. This has all kinds of features to help you test your product. So then also it is written in Java for very quick development and easy porting to any other language that is basically a garbage collected language. Not so easy to port to C is about the only language that's left off of this screen. You notice all of these modern languages are garbage collected and would be very simple to port to. Perl probably be a little weird, but the rest are C-like. All the others are C-like and could be ported relatively quickly. And for those that don't know, the little weird creature down there is Go, and certain large Silicon Valley companies really like that language. So I included it in there. So that's it. That's what the reference implementation is. And that's the longest you're going to hear me drone on about anything in this question and answer format.
Wow, that's a lot of stuff. But if someone purchases their BACnet stack from a third party, is your reference implementation still going to be useful for these guys?
Well, yeah, you could, if you get the stack from there, you could say, well, they've already done all that negative testing and all that stuff, the packet formats and the messages, unexpected messages. I don't have to worry about that because somebody's already figured all that stuff out. However, when you put it in the field, you still have to test your product. And especially if you're making hubs, something like that, where you have to worry about scalability, then this is one of my favorite pictures I came across. Anyone who is a StarCraft fan will recognize this. Those are your hubs. That's your primary hub and your failover hub, and they're being attacked by zerglings. And zerglings are the nastiest little creatures. You can step on them, but when there's 1,000 of them, that's a problem. And so just like your hubs in the real world, you might be able to connect to one or node, but 1,000 nodes is going to cause a problem, maybe more than 1,000. So one of the things that the reference implementation does is it lets you quickly fire up 1,000 nodes to attack your product without having any requirement for physical devices or real networks. So it can be used in that way as simulations for scalability.
Cool. So, yeah, having done most of this and worked through developing this reference implementation, how much work is it to actually add BACnet SC into an existing stack?
Well, if you were part of the discussions or saw any sort of presentations that I've given in the past on this to the public, we really made sure that BACnet SC was just like any other data link. As far as the BACnet stack is concerned, it looks pretty much just like MSTP or IP. It comes into the bottom of the network stack, same kind of messages. I'll explain one difference later on. But for the most part, it looks like any other data link. So you think, hey, no problem. But what makes this slightly different is that it's a beast for what you might have if your product right now speaks UDP on IP. That is a walk in the park compared to SC from a heavyweight standpoint. So your RTOS must support, whatever you're using must support TCP. That's obviously not a given in some environments. Then you have to do TLS 1.3 if it's not already built into your platform, because TLS 1.3 is not part of the OS. That it's an application level protocol, and most people don't know that. A lot of people think it's just part of, it's like right next to TCP, but it isn't. Every browser you get, it's built into the browser. It's an application level thing, and so you have to find a TCP, a TLS library that works. Then on top of that, you have to find a WebSocket library that works. And you might find this really great common WebSocket library, but then you find out, oh, but it uses POSIX threads. Oh crap, well, I'm not using POSIX threads. So you got to worry about your library matching your threading model. So these are all the things that you have to do. Everybody supports UDP datagrams. I mean, that was a baby step, but this, of course, then your CPU has to be able to support the handle, the load of the encryption and the certificate validation and the PKI stuff. So that's what makes it different.
So what challenges do you think a developer will face, or maybe we should go back to the other question. What makes adding BACnet SC more complicated than other data links?
Yeah, well, just to continue on that, there's the one thing I said I would mention, that there's one little bitty difference between this and the other data links, and that is in the past there was this section in the standard, for those who know the standard well, that was this security parameters, and that was something that was thrown in there for clause 24 security, and most people completely ignored this paragraph because they didn't have to think about it. Well, in BACnet SC, there's this also thing in clause 6 now that says the network layer must support the forwarding of data attributes. What are those? And that means for the first time ever, this little indication there, when you get a message and you send it to the network layer, there's this little thing called security parameters, and we crossed that out and we called it data attributes, but it's still now something you can't ignore if you're doing SC to SC routing. And so let me back up and say that if you're not doing SC to SC routing, you can still continue to ignore this. So it really doesn't change your interface. So if your network layer is expecting these, to get messages and send messages, and it's only routing, maybe it's not routing at all, or it's only routing to IP or MSTP to and from SC, but not SC to SC. As long as it doesn't do that, you can ignore these 3 slides. You can go on with life blissfully unaware that there's any changes. So, but when you're doing SC to SC, these data options we're talking about are conveyed in this place in the SC message, and they need to go up into the network stack and back down the other SC layer. So that's what makes it different than other data links. So,
so once someone jumps into this large task of implementing BACnet SC, what challenges do you think they will face in debugging their BACnet SC implementation, and how can they go about mitigating them?
well, again, this is it's just like every other data link. However, it's way more complicated, and so these are some of the things that can happen. It can have very large APDUs. It might have 2 communication paths for the first time ever. Normally, you just send a packet and it gets to the other end. Now there's 2 different ways of getting to the other end, even on the same data link. It might have lots of connections, and it does in this one little data link. What used to be a datagram thing now has multiple state machines. State machines are nested, so you have basically connections can go through their states, and then the connection owner has his own state of whether I'm trying failover or whatever. And then even then, when you're in the connected failover state, there are substates of I need to go back, and in this state, I still need to go try my primary to see if my primary is up again, and then switch back again. So lots of nested state machines. It makes it quite complicated. There's no standard way to configure this. So what the reference implementation yet, I mean, we're working on that. For those on the committee, we're working on a network port. There's no standard way to do it at the moment, and the reference implementation just takes its job as a test tool seriously, and so it's very simple to create. I have a picture of it later. I'll show you. It's just configured by text files properties, and so you just edit the text file. Now that can be done either by a script generating the properties file or you typing it in manually, but when you say go, it just runs. No need to talk to it over the wire to give it anything. It just runs. So and also to make this portable, to make this simple, all of those properties that are in that text file are the stuff that would come out of a network port object in the future, but they're all gathered in one place in the source code in one object, and that object is handed down from the application level down to the data link. So even in the future, when all these properties come from a network port, the code will remain largely unchanged because the data link gets all of its properties in one big bundle. So now you mentioned what kind of challenges there are and what makes this difficult to debug. And mainly the first thing is it's TLS, so you can't see it. Wireshark can't decode the contents. And so for those really into Wireshark, you know that Wireshark can decode 1.3 if it's given a secrets file. This is the pre-master secrets, and if you figure out a way to pull that out of your stack and poke it into a file, then Wireshark can pick that up. It monitors the file. It can pick that up out of the file and use that to decode stream. And so it's pretty good, but then you end up with a stream of octets. And what do you do with that? Because basically the framing is missing. And so BACnet, you need some way of interpreting that stream. So just saying, I need to get Wireshark to decode TLS 1.3 doesn't really get you very far. However, if you do want to see the WebSocket exchange and stuff, the reference implementation supports plain WebSockets, and that is something that's really cool. So it's not a standard. You can't do this in your final product, but if you just say WS: instead of WSS:, it will attempt to do a plain WebSocket, and then Wireshark works just fine. If you really want to see that stream of octets that is the WebSocket conversation, you can do it in Wireshark with no changes to at all. But the main thing is that even if you get the decoded wire messages on the wire, all the internal stuff is still hidden to you. The state machines, the transitions, the interpretation of a message. If it doesn't respond if it doesn't respond with an error, then how do I know what you thought of it? So this kind of thing is important to have. The reference implementation does extensive amount of logging. So here it spews out its interpretation of what's going on. I got this message, here's what I thought of it, here's what I did in response to it, here's how I changed my state machine as a result of it. So that's the most important thing that this reference implementation can do, is spill its guts to you. Now, logging is a religious thing. Different people have different opinions about how to do logging, and so the reference implementation is a hands-off way. It uses a standard facade for that, so you can use any kind of logging backend. You plug in all these different ones. There's an amazing one called Logback, which is a terrible name, but it's an amazing logging application framework that lets you customize the format of the messages. You can do the timestamps any way you want. You can rearrange stuff, do things, filter it, do anything you want, and you haven't changed the code in the reference implementation at all. So logging is completely flexible and driven by you without having to recompile anything. So.
Okay, so with the debugging in mind, how will adding BACnet SC to a product affect QA in their processes, or will it?
Well, the nice thing about it is that this can be a partner in your automated quality assurance thing, where you don't have to hack your own code. You have, let's say you have your implementation and it's working great, but you want to go up against something that deliberately misbehaves and that kind of stuff. So rather than taking your code and filling it full of instrumentation and logging and exceptional cases, use the reference implementation source code, hack on it, do whatever you want. It's designed to be fairly simple to construct new tools with, and that's how it works. And so, like I also mentioned, that there's other stuff that is involved around BACnet SC, and that's all the stuff to do with certificates and certificate management. So there's more to this reference implementation than just the Java code in the executables. And part of this delivery that will be a community vetted thing is the script files that are used for using OpenSSL. But if anyone who's done anything with OpenSSL says, how do I really make a certificate authority? How do I deal with that config file that sets the serial numbers and all that stuff? You can Google for hours or days, and believe me, I have Googled for hours and days on this topic. And as a result of all that Googling and reading, I've made some script files, some scripts that will do this kind of stuff and make a CA, make intermediates, sign certificates. So now the best part of this is I'm not going to claim that this is all correct, but as a community, we will agree, the participants in this program will agree that these scripts are correct. And if we all do it in a compatible way, at least we know that when we hit the field, that our certificates will have been made in a way that work with the, again, transitive. If our certificates work with certificates made by these scripts, then you can be pretty sure they're going to work with certificates made by others. So.
Cool. So it sounds like there's other things that you're giving us in addition to this reference implementation. What kind of pre-made examples are you actually throwing in with this reference implementation?
Right. Well, just throwing a bunch of source code at the participants and saying, here you go, knock yourself out, I think is great because my job's done, but I don't think that's very useful. Not everyone's going to want to compile Java. Not everyone's going to want to even see Java. They don't, have an IDE for it, that kind of thing. So to make things simple, what I've packaged up those three components that we saw in the earlier slide, basically the orange, blue, and green, I guess, the nodes and the router and the hub. And so that you'll have basically three pre-made executables that will be delivered to run on Windows or any other platform, Mac or Linux. So they'll be tested on all three. These pre-made executable, the pre-made node, for example, will be obviously do all the correct things, connect to primary and failover, but it will also accept direct connections or not. And that's where the or not comes into the configurability of these pre-made examples. So the pre-made examples are useful, but if they only did one thing, then they wouldn't be so useful. So I'll get into the configuration on the next slide. So this node can initiate direct connects with some sort of manual. You can say, if you see a VMAC with this VMAC address, then try to connect to it, or do it now and then disconnect. And so there are, again, manual interventions that will be done, driven from the command line. I mean, from an interactive shell with the node to tell it what to do. And it, of course, includes just the device objects and the minimal stuff. Now, the hub can act either as a primary or failover, because obviously there's no difference between them, but it can also act as both. And that just saves you some time. You have one thing to interact with. You can say primary up, primary down, failover up, failover down. You can talk to one executable, and it has on 2 different ports. It's both a failover and a hub. You obviously wouldn't deploy it that way in the field. It's not a product, but it's a great testing tool. So this thing can be a node or a hub or both hubs all at the same time in one little executable. And then the cool thing that I think is neat, another protocol violation that is done in the name of testing, is in the hub, you can turn off the internal node. The internal node in a hub does nothing but annoy you when you're trying to test your node, because your hub always has 2 nodes in it, and one of them is just the hub itself. So that's just noise. So you can turn that off. It's a violation of the standard, but it makes the logs a lot simpler. So, and then also the router can route between BACnet IPv4 and SC, obviously, is the main use for it. And you just give it the network numbers and give it the IP addresses to bind to in the text file, and it'll do that. But you can also do SC to SC binding. And the nice thing is it can all be done on one NIC, because it's just one IP address. You could have as many SC ports as you want on that. You can only have one IPv4, of course, support. So, and then each of those can be hubs or not, each of the SCs. Now, I talked about these. So these pre-made examples are driven by these configuration files, or everything's driven by the configuration files. But you can see some examples here. The cool ones are like, is hub, is node. That's the way to turn off the node. You can tell the node whether it accepts direct connects or not. And you can also play with no, you just say no TLS true, and you have plain WebSockets. You can also change to TLS version 1.2 if you want with the version. And you can also say, my gosh, this certificate stuff is such a pain. Will you just connect and accept anything? So you say no validation true, and your life is good. And only when you're coming to like the end of where everything finally works and your stack finally works, then say no validation false and start dealing with that mess.
Well, so I know I'm wanting to get my hands on this. So how will the reference implementation be delivered to the program participant?
Well, everyone but Carl can get it. No, the participants will get a copy of the source code, obviously, because we want you to look at the source code. The source code has a no-cost license for you to do as a participant in this program. You can do whatever you want with it. Port it, build it, change it. Hopefully, let us know where there are flaws in it, and that will benefit every participant. Certainly, if you're testing against it and you find any reason to think that the reference implementation is wrong, then it's obviously something that needs to be fixed. The examples, as I said, will be pre-packaged to be with a redistributable Java runtime, so you don't have to even worry about it. Hopefully, if you don't want to ever hear the word Java, you can just run the examples and edit the text files. So those will be shipped as part of the program as executable Windows or Linux or Mac executables. And then if you do want to get into it, all the source files were done in IDEA, which is, as far as I know, the best package. It's free, so there's no IDE to buy, so you can just get right in and start hacking and debugging. So that's how you'll get it.
Okay, so if someone buys their stack from a third party and that stack implements BACnet SC, do they need to concern themselves at all with BACnet SC beyond just incorporating the new stack into their product?
Well, as I said with the Zergling attack, you always need to worry about scalability and how your product will perform in a real world, and that is your how your OS and your encryption algorithms and all that stuff work, that may not be part of the stack unless the stack includes all of that, and that's a pretty bold stack. Most stacks are just a library that work in your environment. But the SC needs go beyond just the stack, and this is different from IPv4, for example. A little bit similar to MSTP, where the stack says, look, you know, I need serial characters, but I have no idea how you're going to get them or how the interrupt routines work or any of that kind of stuff. But, you know, please just give me a bunch of bytes off your wire. Well, this is a little more than that. So you have the stack, but then there's stuff outside the stack that is basically all the certificate management, how that works. These tools might come from the stack provider. The stack provider might have suggested tools, or you might be part of a giant ecosystem provided by your stack, so by the stack vendor. But in any case, it will have to be integrated into your workflow, and you'll have to train your field personnel on how this works. And at the bottom, I emphasize that your device will be able to generate the certificate requests and send them somewhere and get the answers back and stick them back in. So for the first time, SC, when you go on a job and you're not the primary contractor, you're not one of the big manufacturers that has a broad product line, including all of the tools in the front end. If you're going on the job as a device vendor, then you're going to have to know how to play with the environment that you're going into, and at the very least, it's you generate these the requests and you send them off somewhere and you get the answers back. So, and that's something that is unique to SC. Everybody else is like, just tell me my IP address and I'll type it into my tool and I'm done. So this SC is going to force more interaction with other vendors and with the ecosystem of whatever is driving that site. So it's more than just quote the stack, I'm afraid.
Okay, so is it going to be easier or harder to implement BACnet SC in older or newer protocol revision products?
Yeah, well, we talked about how hard it's going to be to implement SC. Hopefully, things like the reference implementation as a testing tool will help you along your way. But I would say because SC is unique, for those who haven't heard, and I may be preaching to the choir for everyone's heard this many times over, but SC is a unique addendum to BACnet standard because it is something that can be adopted without regard of protocol revision. And that's an absolute first. We've never done that. The only thing you could do previously was engineering units and error codes. That was about it. Everything else, if you wanted some goodie in the standard, you had to implement the standard up to that point. And that was a high burden. And people have years-long development cycles, several years behind in many cases, just because of the burden of getting up to the latest standard. Well, SC wanted to cut through all that and lets you just go immediately to implement SC in some way. And it does, so it didn't make any requirements on network port objects or anything like that. So my suggestion would be don't update your whole stack to the latest version just to develop SC. Start implementing SC right away, implement it on whatever stable version you've got, because you don't want to be messing with SC is complicated enough. You want to implement it on a stable version, and because it has this nice network interface, and because unless you're doing SC to SC routing, I know from experience you can bolt this on to the bottom of an existing environment and it works really well. You don't have to change your stack to get SC up and running as an isolated data link. And so that's what I would suggest. And then of course, if you want to rev your product before you ship it, that's great. But this is important. So the reference implementation, just to prove that it doesn't need a network port, and also to not have to write the network port. It doesn't have one at this time. Now, as soon as the network port proposal goes through and it becomes a standard, as soon as there is a standard network port, in other words, the reference implementation will obviously be updated to be a reference implementation of that as well. However, to be portable source code, the reference implementation, as I mentioned before, the data link is going to get all these parameters from the network port packaged down into it in one little blob of properties, and then that's handed down to the data link. So if you want to use the source code independent of a network port, even in the future when the reference implementation does support the network port, you can still do it without the network port. And I hope that was clear. But we have this real strong line between the network port and the SC data link. And so to prove that the SC is independent of that. So, but if you do put this down in an embedded device where you don't have config files to drive it all, surely these properties have to get to it somewhere from something. So you either have proprietary objects on the device object, or you do have a network port and you put proprietary objects on that, or you have some other means of configuring. I don't care. Put this stuff, send a file down and let it parse the text, anything you want. So those are all the challenges there.
So when will participants be able to get a beta copy of this reference implementation?
What was that? I'm sorry, you're breaking up. Oh, no, it's this is mostly done, and I'm basically right now finishing up the direct connect aspect of it, the manual commands to initiate and tear down direct connects. So it's well underway. It's been stable for quite a while, and we hope that we'll be in beta of all this and well, let me advance the slide to make the commitment. Beta March 30th. So the month of March will be spent basically writing documentation as to how to tell the participants how to use this tool and do a bunch of suite of internal testing before we turn it over. So hopefully in March, even though it's called beta, it will be nice and stable for you all to begin working with. And then of course, we anticipate that you will have some community feedback on that. The participants will have a chance to weigh in on maybe changing some of those behaviors. Some of the things we identified as error codes that, well, you chose, the standard doesn't say what that error code is, but you picked a really bad one. So let's change that and make it somewhat more consistent, or let's make a proprietary error code. Anyway, we'll have discussions. So between March 30th and June 30th, we'll have those community discussions of the participants, and we'll all sort of polish it up. And then in June, we'll say, okay, this is it. Everybody can start testing against that and be fairly convinced that it's correct. And then after that, some period of time after this is all said and done, and this program ends, all of this will be released to the wild, out to a public open source repository where the public do anything you want license, and we'll go from there. And that's probably when things like the network port will be added to it and that kind of stuff. Because we obviously we won't have the network port done by June 30th. So that's a follow-on project.
Oh, well, thanks, Dave. That's been a lot of information that you've given us here. I think it's time to pass it back to Andy. So.
Yeah, I'm sorry. That was maybe speaking through a fire hose, but we had a lot of good slides to get through there, and wanted to make sure we got through them all. So.
No, that's actually great. Thank you, Dave. And let me remind the participants here that this is being recorded, so we expect to post a link to it in the forum. So you can go back and play it on slow and capture every word that Dave said.
I was just going to suggest slowing it down, maybe.
In addition to that, the slides that you saw that Dave used will be available through the forum, probably as a link to somewhere where it's going to be stored. So you can go back and look at things and review them. And as you do that, you may well have some more questions. So feel free to post those questions in the forum. Dave and Carl and a bunch of other people are watching the forum, and we'll give you answers and explanations for things that come up later. There are a couple of questions. I think we have time for a couple of questions that we heard from participants already. One, Dave, is kind of it's a sort of a trick question, I think, to see what you can do with it. But so how many nodes will the reference implementation of the hub support?
That is a trick question because what iron are you running it on? So I haven't actually fired it up on my laptop to find out. I did a quick little test. I told the source code to generate 10 nodes and attack me, and of course the log exploded. But that's a good question. I hope to run those tests before March 30th when I turn it over. I as an arbitrary challenge, I think it would be fun to see what it would do with literally 1,000 nodes. And so the right now the script is designed to support. I don't want to have to fire up 1,000 instances, right? So one of those hacking things is, which is not included in the pre-made thing, but I'm hoping that maybe this month I can create a pre-made executable that is n nodes. And so you just, in the configuration file, you tell it, how many nodes to make, and it will simply, because right now, if you saw those in those the slides of the configuration, it's basically talked about one node. What's the node's VMAC? What is all that kind of stuff? And so I don't have a way of programmatically, I mean, right now, the code that I use to test it, because it's a hack, I showed the little hatchet there, it actually just incremented the VMAC and incremented the device ID and all that kind of stuff programmatically. So I just put it in a for loop and created a bunch of nodes. And that's probably where we'll end up. So it's certainly something that anybody can do with the tools. And that's why I mentioned the little slide I had that showed the hatchet on there, showed how I was basically creating IP data links and creating SC data links and then attaching them to the bottom of the network layer. And likewise, you can just create nodes in a for loop. I mean, it's all just a couple lines of code. It's a high level toolkit designed to be quickly make what you need. So
good, thank you.
That's a nice political way of sidestepping that answer. Is I don't know yet.
Is it fair to say that by the time we release it in beta form at the end of March, we will have at least tried to make 1,000 nodes and see what it does?
Oh yeah. That's a goal.
Okay, right. So we'll at least have some testing at that point. A related trick question, since you're so good with trick questions, is so how many nodes would a typical hub, say one that you'd implement on a router, be expected to support in the real world?
That's a really good question. And I have always, I think, the 10,000 node hub in the cloud is probably a really, really bad idea. And so, BACnet network routing is there for a reason. It's good. We left it in there. We didn't get rid of it. The clause 6 network layer is there. These are just data links. This isn't intended to make all of BACnet, 16,000 devices on the Cornell campus. We're not intending to make them all flat. It's still collected into networks. So you can do it. In other words, you can do like a local network broadcast, and it's not a global broadcast, doesn't go everywhere. So networks are still a good idea. So I would imagine that even if your building had 1,000 devices in it, or let's say your East campus had 1,000 devices in it as your primary hub, so they can all talk to each other, I think maybe a router device, and that might be a PC class device, rack mount kind of thing, to do that. But then the backup, the failover hubs, I've always said that there could be multiple failover hubs, and that might be just part of your router. Your normal router function, any router that's routing to MSTP or whatever could take over as the failover hub, and there hopefully not more than 100 connections to it. And they might be slow, but it's It's the failover mode. It's not intended to be high performance. So I think that's what we're going to see. I think we're going to see high performance hubs that can handle probably 1,000. We'll see how the market pans out. That's still sounds like an awful lot. I can't imagine it being more than that. And then the low end stuff, low end routers that act as the failovers might be 100 or even fewer. So just to keep things running.
Okay, so that really is more of a product and how the industry evolves question than a technical one.
Yeah, it really is. The standard is designed. The key to me, and this is it, for those in the meetings, you'll remember I always stood on a soapbox and made sure that the standard supported multiple failover hubs and one primary hub. So it isn't if a failover that takes the place of the primary. These are not equals. Like when this one goes down, this one takes over. This idea of a primary hub, which is doing most of your work with its logging and maybe it's doing filter, who knows what it's doing. And then when that dies, poof, because that might be through your ISP connection to the internet or something like that. But then the idea of multiple little failovers just to keep the stuff running, just to keep the air handler talking to its zones, for example, is a good deployment idea. So the standard does support that, and we'll just see how the industry shakes out.
Good.
But
Good.
At least it's flexible enough to answer that question in the future instead of tying your hands to say it's like for those familiar with BBMDs, the standard required all BBMDs tables to be the same. That's what the standard said. The distribution of all BBMDs is the same. And then the market very cleverly said, you know what? If we do this split horizon stuff and we start doling out who can talk to whom in an intelligent way, yes, we're violating the standard, but you know what? This is pretty cool. We have asymmetric BBMD tables. So we kind of learned our lesson, or at least I wanted to make sure we learned our lesson here. And so we have asymmetric hub model built into the standard right from the start. So your failover might be exactly equal to your primary, or it might be a different strategy. And the standard now makes that official instead of sort of a creative violation.
I like that creative violation concept. The rebel in me thinks that's really fun. So the reference implementation you've written is in Java. You showed us that. Are you going to, just for the fun of it on the side, make a C++ version and give us that too?
Oh, the fun of it, sure. Well, yeah, between March 30th and June 30th, I won't have anything to do because there aren't any bugs in it. So no, we'll see what the year brings. I think a managed C++ or the C++ CLI part of the .NET framework, I think is intriguing. That's interesting. I've always wanted to play with that. C#, of course, would be a lot simpler to migrate to. And then, Python would be fun. A lot of people like Python. Who knows?
Okay, so putting on my president hat for just a minute, let me point out that the program doesn't commit to do that.
Right. No, yeah, absolutely. Neither do I.
Or for that matter, one of the participants might do it and feed it back and say, hey, Dave, add this to the distribution, and that'd be fine too.
Right.
If someone were going to do
one of the other languages I wanted to mention, though, is anybody who's going to do it for an iPhone, whatever, would be using Swift probably, or at least Objective-C, and that's not a far reach from the simple Java. I should have said, and I might have said that the Java is written in baby Java. If you read it, you're going to go, wow. Well, I did use generics and a few exceptions, but it's single-threaded. Doesn't use super fancy thread pool dispatch things that are going, how do I port that? It's basically a gigantic set of state machines. It's designed to be ported to any language without regard to its threading model. It's basically doesn't use a lot of clever constructs. It's not a bunch of callbacks. It doesn't use lambdas. It doesn't use a lot of the modern Java features. And it did that because it doesn't want to be Java. It wants to be a reference that can be ported to other languages as well.
Good, good. We have a number of questions that we're not going to answer here around certificate authorities, where they might come from and who might be one and how might users use them. And so I'm going to make sure we feed those into the forum where we can have a robust discussion about it, because there's not a correct answer to those.
Right.
There's an industry will evolve kind of answer, and maybe we can help shape that as a community. But we'll put those in the forum and have those conversations over the next several months, I think, and see what evolves as kind of a consensus and what would be most likely, at least.
Right. Yeah. Those slides I showed with the big purple text and the scripts and stuff, and that's I don't know if I can get back to it there, but that well, participants will have the presentation so they can see it. The big purple text there was the configuration file that you have to create on a disk somewhere that sets up your certificate authority. So yes, you can do everything from the command line, kind of have stuff just go poof and evaporate, but you don't want to do that. These things should have serial numbers, and that should be driven by a text file somewhere in the certificate authority environment. And there's all kinds of policies that are set up by that environment. So the scripts that I wrote create that certificate environment, CA environment, on your disk somewhere, and from that you create an intermediate certificate, and then you use that to sign the certificates, all based on that policy file. So it's a little, as I got into it, it's a little more complicated than just typing some OpenSSL things on the command line. When you really want to become a certificate authority and generate the certificates. So hopefully that's the kind of thing I'm definitely looking for feedback from the community. Everybody might have done it different ways or read different Google articles than me, and we'll combine them all into one best practice.
Okay, good. We're getting down to the last couple of minutes, and I want to be respectful of people's time. So let me say other questions we'll put into the forum. We'll deal with them there. Along with that, of course, the forum is the place where we'll do our first announcements of future webinars. Right, we plan to have a couple more. Exactly what they will contain depends a little bit on feedback we get from all of you who are attending this one. So you'll receive a survey from this one. We'd like to get your response to that so we know how well we're doing in meeting your needs with these. But it'll also provide some opportunity for you to tell us what you might like to hear about next. We are thinking specifically about doing perhaps something around how to use the tool as a platform to build some additional, more robust tools for your own in-house use. Maybe another one that deals a little bit with deployment of BACnet SC and this question of certificates and hubs and certificate authorities and how all that might work together. So those are the ones we're thinking about, and they'll get a chance to give us your feedback on those. If there are other people in your company who have not signed up to the forum, who might be important product managers and developers who might benefit from seeing what's going on there, be sure to let them know. As your company is a member, that means all of the people in your company who can make use of this information can participate at no extra cost. I think that's it, except in general, let us know how we can shape this program to meet your needs. We've tried to spend this hour productively for you, and we'll do the same in the future. And with that, I think we're ready to sign off. Thank you all. Thank you, especially Carl and Dave.
You're welcome. Thanks.
A real live Carl and Dave show, as the committee used to say.
Right.